So if you are out there, and Marty, you should come and sit here.
Okay. I have to leave early, Warren, so I'm going to... I don't want him here. He's going to deny all these stories.
So I'll just say a few words about Warren. But, you know, I have been here for 20 years, and like came here, Warren was a senior faculty member. Right? So, so Warren came here in 1976. And I would guess probably 80%, 90% of the audience are not more than. So he's been here for 39 years, if my count is correct. I don't know if, you know, Warren is known for every single undergraduate and graduate student, you know, who probably passed through this college in the last 38 years came through Warren hands. If you go to get a degree in math, you have to go through advanced calculus. If you go through advanced calculus, you go through Warren. And you know, it's a hard class to teach. 2 years I taught it, and 2 years maybe somebody else. I think Lucas taught it for a while. And if you want to do it well, you have to go through Aristotelian method. You have to grade every argument. You have to look at every single thing which students write, and it's extremely time-consuming. And if you don't do it, it doesn't work. Right? So Warren has done it for decades, and so he is basically a legend. He also developed a new course, Methods of Proof, a couple of years ago. And it's another class which now everybody who wants to know something about the reasoning in mathematics has to go through. It's an essential course in the math program. And if you know, but Warren also had done a lot of research. I mean, he wrote 51 papers in his career. And this is diverse in statistics, probability, math education, and even numismatics. If I remember correctly. So Warren was always a person who if you want to know something about undergraduate or graduate, you know, classes, what has to be done, he always has opinion, a firm opinion, which is not going to be wishy-washy. And it was always it was always to have somebody with a kind of a backbone, saying this is how things should be done. So, as you know, probably Warren is going to retire soon, and it will be a huge loss for MSU and a huge loss for all of us. So let's see what he has to say today. Warren.
Well, I want to make at least a few people happy they came. Who would like a Rubik's Cube? Okay. You know, I've been giving away books, but I've been saving some of the key ones here. This is for a math educator. Somebody who teaches math education. Who teaches math education? Okay. You might have to teach geometry one of these days. You never know.
Oh, this is Thomas Little.
Now, this is an interesting book. It's mine. And I wanted it when I was in high school. And I bought this book. Logarithms to 7 decimal places. And here we are. We want the number. Here's the number, and then this is the next digit. And then there's linear interpolation over here. So that you can just get that nicely. And then, when I went through school, we had slide rules. I'll show you one of those in a minute. But if you want to multiply stuff, people use logarithms. Real pros use logarithms, so I want to be a real pro, so I got the logarithm book. Now, think about the law of sines. If you have the law of sines, you get A over sine A is B over sine B. And if you want to solve for A, that gets you sine A times B over sine B. Now, that's a lot of multiplication and division if you want 7 decimal places. So, what you really need is logarithms of the trig functions. So that then you can use properties of logarithms right here. And lots of decimal places and degrees and minutes and seconds, and then linear interpolation between that, just in case you really want to be accurate. And I think this book belongs to History of Math, and he teaches. Now, Is anybody here going to take some dynamical systems one of these days? I'm looking for a graduate student. Dynamical systems? If you don't have this book already, I don't see how you can be in dynamical systems. When I was in school, everybody had this book. It was cheap. It's still cheap. The World of Mathematics. 4 volumes, all the cool stuff that was ever written prior to decades ago. And it's got some really good stuff in it. And I'm looking for somebody who actually reads mathematics, not just does the very minimum. I didn't think so. That's a great book. And in the old days, everybody used to read this book too. What is Mathematics? Courant and Robbins. Courant was a very famous mathematician. It's got pictures. When I went through school, I won all the puzzle competitions. And the reason I won all the puzzle competitions is because I'd read all the puzzle books. And the guys that wrote the puzzle competitions, they'd read the same books. Martin Gardner, really great stuff. I got the Hungarian problem book. Well, that's not so easy. The second Hungarian problem book, stuff like that. A little later, somebody can come get those because I don't have anybody particular in mind for that. Here's a book called The Mathematical Tourist. This is written by a guy who's not a great mathematician, but he told me stuff about fractals. Look at nice pictures. Somebody? Yeah.
Parker.
Al, I don't want to toss it. Bring it back. Okay. Here's my laser pointer. Appropriate for Bozeman, you know. When I went through school, we had these things. They hadn't invented the photocopier yet. Can you imagine life without a photocopier? Well, they hadn't invented the photocopier yet, so we used mimeograph. Yeah, it's a mimeograph. You type nice and hard on a piece of paper, and it broke through, and then let the ink through, and you ran them off, and it's a lot like a risograph. A risograph isn't that much better than a mimeograph was, but we did that a lot. Oh, I forgot to teach you about logarithms. Here's how you do logarithms. Let's see, can you see on this? It's pretty hard to see, but right there is a 2. And then right here is a 3. And if you put the end on the 2 and the 3 and look below the 3, it gets you 6. So you knew that 2 times 3 was 6. But you could do that for other numbers too. See that 7 right there? Well, you probably can't. It's pretty small. Let me zoom in a little bit here.
You can see it.
You can sort of see it.
There we go.
That's not really 7, that's 17 because the 1 starts over there. So that's 17, and if you want to multiply that by 2, then you get over here. This is your cursor to line it up. And you can do square roots and any powers and all that sort of stuff. I won slide rule contests when I was in school. That's how you did multiplication if you only wanted 3 digits. You didn't need your 7-digit book. Yeah. Now, I've got another book for a new faculty member. Jenny? Cheers, back to Jenny.
The only thing I want.
My wife told me not to try to teach you anything. But I just can't help it. I'm going to give you some advice. Color-coded folders for your class. This is methods of proof. I can tell it apart from analysis because analysis is red. I keep lecture notes and exams together, and I pile up old exams, and here's something I really recommend. Stick on your exam how the people did. That doesn't look too good, does it? You see, I'm at C's down to here. Now, if I write that exam again and give that another year, or a similar sort of exam, I might think my students are really bad this year. But that way I can go back and look and see, oh, they're not so bad. They were just as bad years ago. Now, I've been in charge of pre-calculus for a long time, and this is one of my favorite problems. You ever heard of f of x plus h minus f of x over h? This is a photocopy of an answer. Somebody got that wrong. And at one stage of my career, I was irritated by this stuff. So I got myself a little stamp. Now, is there anybody in here who's got guts enough to tell somebody they can do them bad out? I always put this one up first day. I really like that one. Well, I always felt that way. Okay, let's see. I have a little note here. The exam questions don't need to be clever. It's something that beginning faculty have a tendency to do. They've been studying math for 10 years straight, and they finally found a problem that interests them in calculus. And they give it on the calc exam, and nobody gets it. Because if you've been studying math for 10 years, it's too hard for the freshmen. So I'm suggesting you don't ask those. I'm also suggesting you post old exams on the web, because students deserve to know what your exam format is. And if you don't, then the frats have the advantage, because they keep track of all the old exams. I put a couple of phrases, and they're on your handout, that I thought you might like to put on exams. One is, correct answers with little or no supporting work will get little or no credit. I really like that, because occasionally you get an answer that's 100% right and there's no work. And I figure that means the guy's got 20/20. And I would like to be able to take points off. I want to talk about makeup exams. I think you should consider giving them. Sometimes you get a student who comes to you and he says some bad excuse. And you're thinking, I don't want to write a makeup exam. Well, that's true, you don't want to write a makeup exam. But I've got lots of old makeup exams. I've got exams from 1995. There's no way the guy's seen that exam. I can just give him the old exam. Now, recently, well, actually it wasn't this semester, but a previous semester, I had a student, I wrote this down at the time because I wanted to get this right. I had a student complain she did not have enough time on the recent pre-calculus exam and lost a lot of points for not having time to do the back page with its 2 long trig problems. And she sat in my office and explained all these various things. She was really good at trig, and exam was too long, the TA was bad, and she wanted her money back, and it was just going on, and I didn't know what to say. And then it hit me. I grabbed a blank copy of the exam. I said, go out in the hall and take the 2 trig problems. 15 minutes later, she had nothing on it, and she just walked away. She did not know how to do the trig problem. She was misrepresenting whatever. And whatever happens, whenever anybody has a bad excuse for a makeup exam, give it anyway. They'll get an F. It never fails. I sometimes have to give exams just a little bit before the normal exam, and I don't want to write a different exam for that. So I put an honor pledge on there, and I sort of like this. You might use these wording. This is also on your handout. I promise not to discuss this exam with other students until after the regular exam has been administered. If asked, I agree to simply say I can't discuss it. I think that gives them something to think of when They walk out 20 minutes early, and their buddy says, "What was on the exam?" Just gives them something they could possibly say. Okay. I was going to say, students are supposed to learn, and I'm wondering how you ought to handle homework. I'm not supposed to teach you stuff, and you don't have to believe me. You don't have to take any of my advice. But how should you handle homework? Some people actually score homework and put it in their final grade. And I think that's not such a good idea because I don't expect people to learn stuff overnight and have it by tomorrow. I expect them to learn it by the end of the course. So instead of scoring homework, I mark homework. I give them all the feedback from that, but I don't actually turn it into a number. But I think students do want to know how they're doing, and I think you ought to give realistic letter grades early and often. There are some times when people give a low number course, and a person gets a 55 on a calc exam, and the student has no idea what it means. It looks like it's a really bad number. But maybe the calc exam is going to be curved a whole lot, and it's not a really bad number, or maybe it's reasonably bad, but I think they ought to get letter grades fairly early and often. And I'm pretty concerned about negative feedback, because in today's world, people don't want to get negative feedback. You sell on eBay, 100% positive feedback. This guy was perfect in every regard. I don't know. People can't take negative feedback, but I think in our profession, that's part of our job. You've got to give some negative feedback. I think it's a good idea to give negative feedback early in the course so the student has time to change. In fact, I think a course like pre-calculus is very valuable for the university, and I'm not sure the university agrees with me, but I think it's valuable for the university to give some students some negative feedback. Working this hard isn't going to get you through MSU. Same with all the other low-level math classes where the pass rate isn't 100%. I think we're honest. And if you never give negative feedback, then what's going to happen is the next class inherits a student who shouldn't be there because they don't know how to do anything. I have some advice on tutoring. When you tutor, you will find that steps that are obvious to you aren't obvious to them. And if you fill in the steps, you often miss a lot, not recognizing what's going on. I often say, what's the next step? And it's ridiculously easy to divide both sides by 3 or something like that, and the students nevertheless don't really know. I think you've got to realize you're good, and some of them aren't. And when you tutor, you skip all the easy stuff, you may not find out what level they're really at. Multi-section courses. If you are in the process of grading a multi-section course, I think you should learn to grade a couple problems at a time, or as I do in pre-calculus, you give 4-page exams. Okay, you 2 on page 1, you 2 on page 2, you 2 on page 3. We'll get around to page 4 later. And then have them consult, and that way, when it's 3 hours later, they can still remember how they graded that problem because they have a nice rubric. They kept track of how they graded. If you grade a entire exam at one time, you get a little contaminated. The guy did real well in that problem. Well, you must have understood that problem, so you give him a higher score. Even though, if you would have graded that problem first, you would have given him a lower score because there wasn't that much there. I'm going to recommend a book at the end, Thinking Fast and Slow. It's been a very popular book recently. And the guy talks about how when he switched grading from an entire person at a time to a problem at a time, scores changed a whole heck of a lot. Now, teaching. Let's suppose you have to teach something and the student says, how'd you get that step? There's a real possibility that you could slow down and be very thorough. Or there's a possibility you could do another problem like that one. And I have developed a theory that you ought to teach at internet speed. These guys are easily bored, and if you slow them down, then there's one person who's maybe following you, and the rest of the class is wasting their time. If they're having trouble with an example, do 3 of them fast rather than 1 of them at a glacial pace. Now, I think part of our job is to add value to students. And sorry, I'm going to try to give you a math theorem here. I want to talk about what would really add value to students. Well, for one thing, I want them to change. In algebra, you have to think differently than you do arithmetic, so I need them to think sort of at a higher level. And at calculus, I want them to think differently than just at algebra, so I have to have them change to a higher level. And people don't want to change. Eat your vegetables. No, they don't want to change. So I'm going to show you, somebody else should have restarted this. Okay, I have to talk to you about what math we should teach now that cell phones can do it all. You know they can do it all. So, well, this is a talk I gave a few years ago at a conference, and I changed it a little bit for this. You got to admit the world is changing rapidly. Is teaching keeping up? What do we teach? We mostly teach information. If you're in a history course, you teach a bunch of facts. This happened in 1914 and stuff like that. And we teach skills. How do you take the derivative and stuff like that. But the simple fact is, information is cheap. Right? It's on the web everywhere. Facts are on the web. And, okay. Let's see if you can read that. Okay, the guy is basically saying, if you want particular information, it's on the web fast. So here's how it concludes. Why go to college at all? Well, hasn't changed. Okay. Well, computational skills are cheap. If anyone can compute it, Wolfram Alpha can do it faster, more accurately. Cell phones can do it. iPads can do it. I have an iPad app that if you put it over a low-level algebra problem, just put it over it, you don't even have to touch anything. And it answers it just by looking at it. So you sort of wonder, if I can buy, a great calculator for $100, I'm real glad I'm not in charge of pre-calculus anymore. Because I want these guys to have calculator skills. But I don't want them to spend $100. So, okay. So why? Why should they spend $100? They already have a computer or an iPad, so they can just download an app that's free. Free graphing calculator is a pretty nice app. And then I'm sitting there saying, how am I going to give them an exam that uses the calculator? Because they'll be texting their friends, what was the answer? Well, I think this is tough. There's all these things. Back a long time ago, there was Sage Math, even before Wolfram Alpha. And then you can easily get apps now that show all the steps. There are lots of websites that show all the steps to do almost anything. And it's a fact that expert systems are replacing people. Right now, expert systems can read x-rays better than radiologists. Those guys average $270,000 a year. They're going out of business one of these days. Diagnose more accurately than doctors, and every other profession too. So you should be afraid. If all you know is facts and computational skills, what have you got? Almost nothing. There must be something that's necessary. And that's a picture of Newton. And he said, if I've seen further, it's only by standing on the shoulders of giants. I think he meant there was a lot of mathematics that went before him, and he built on it. So, of course, we're going to have to build on some mathematics, but what mathematics? Here's a theorem. This is a theorem. The value of traditional mathematical skills has gone way down. So, how come when I went to school, that was a long time ago, we were doing exactly the same calculus we're doing now. Exactly the same calculus we're doing now. The pictures are better. They have color pictures.
Actually, the calculus, if you look at the chapter from Bernoulli, the same order of chapters we have in calculus right now.
Yes. So, I'm saying, I tell my pre-calculus students this all the time. If you can multiply 3-digit numbers, that's valueless. I mean, who's going to pay you to do that? If you can take the derivative of something that's really messy, who would pay you to do that? If you can integrate by parts, who would pay you to do that? No one. Well, math faculty ought to know how to do that. You know, I actually teach how to do that. I know how to do that. But what fraction of you guys are going to end up being math faculty? Pretty small. But we're still making all the engineering students do that. Huh, I wonder why. I think we should refocus our teaching towards skills that add value. So now I got to ask, what adds value? And you got to know how to use calculators. And to know how to use a calculator, there are some buttons you have to press, and you need to know where the parentheses go. Because if you don't get the parentheses right, you're in trouble. And I presume that when you study math, there's actually some conceptual development going on that requires a certain amount of practice and stuff like that. But I think the number one thing we could do is teach them how to read and to reason logically, which is why I'm so happy to be teaching methods of proof, because that's what I have made that course into. Now, a lot of people say, well, I don't need to know anything, I'll just search. Well, if somebody asks you the right question, you can search, but maybe you don't know what the question is. It must come to mind before you can look it up. And you've got to be able to grasp it when you find it. And the simple fact is, if a student needs to know some math, let's suppose an engineering student needs to know some math. So we make him take a bunch of math classes, and maybe a semester later he still remembers some math. But if he needs to know some math after he graduates, what's he going to do? He's going to call me? Or is he going to have to look it up? He can look it up on the web. He's going to have to read it, though, and he doesn't know how to read. Learning, you have to have the right things come to mind. Something like this. We spend a fair amount of time on this in pre-calculus, and this is not easy. If I ask you to solve that algebraically, using algebra, I hope you see that something is squared. So the quadratic formula might help. Well, it doesn't look like ax squared plus bx plus c to me, so it must not work. No, it does work, and they need to see how x squared doesn't have to be x squared. How about if I ask people to graph that on a TI? Well, pretty soon the new calculators, they'll be doing this just fine anyway, because they know what you mean. But if you ask that question, you need to solve for y. Y equals whatever. And how can you possibly solve for y? The quadratic formula solves for x. So, I think reading with full comprehension is something to help bring things to mind. And this quote is from the 90s. I found it really scary. In 4th grade, you have to shift from learning to read to having to read in order to learn. Half of all kids never make that transition. Half of all kids cannot learn by reading English. Imagine how much worse the statistics would be if they were doing math. How many people can read math to learn math? Well, I'm working on it in methods of proof. How's it working? Why is reading important? Well, first of all, do you think they really can read? Do you think they should be able to? I believe so. Do you think anybody ever taught them to? The answer is no, unless they had me. Whoever required them to, the answer is no, unless they had me. And there's lots of little tricky things here. You got square brackets, you got round brackets, you got wiggle brackets. There's different things. Okay, research. Not me. I didn't do this. You ask calc profs to ask their students if they read, and 8% of them read most of it. Oh boy. Is math a language? Sure. It communicates about stuff. Using symbols, blah, blah. There's all sorts of grammar, syntax, pronunciation, all sorts. You know, if you can't pronounce this stuff, how can you read it aloud to yourself in your mind? And how can you figure out what's going on? Lots of stuff. There's things about placeholders. Okay, how do you add fractions? Let's suppose I said to somebody, how do you add fractions? Well, don't try to explain that in English, because you're going to have a tough time. You got something over something, something over something, then you got to find a common That's how you do it. It's places. There's something in the upper left, there's something in the lower left. Just write it out like that, and it always comes out like that. And you can explain this at greater length. I'm not saying just tell them this, but it does concisely explain how to do something. And when I give pre-calculus, I give a prerequisite quiz and say, what comes to mind? And I hope when you see x plus a, the quantity squared, something comes to mind. I hope when you see x squared minus 9, something comes to mind. I hope when you see x squared plus 9. And how do you solve? Pattern recognition, factoring, this was a... I think math is a language. A very serious language. What's the best way to learn a language? You want your kid to learn Spanish? Put him out in the yard when he's 2 years old and have him play with Spanish kids. That works. Best way to learn a language? Start very young, use it a lot, interact with others who use it. Uh-oh. We're in America. Our children can't start young. Elementary school teachers don't know the language. I'm trying to get them over in the education department to send them to me. They're sending about 7 a year now. They avoid it. The curriculum lets them. We often start the language in 6th or 7th grade or later. By that I mean algebra. And that's too late. Few elementary ed students ever do any extra math. Nobody has a course like this except us and a few others. And linguists say, hey, it's difficult to have and think thoughts without proper language in which to categorize and express them. And if they don't have the language of mathematics, I don't see how they can keep things in mind. Learning theorems, quadratic. Look at these bottom 4 lines on the quadratic theorem. The 12's on the wrong side, so you're going to have to make that a minus 12. And the next line you're going to have to solve for y, which is a little bit tricky. Next line is the law of cosines. And if you ask people to solve for b, okay, that's not x, so you can't do it. Then the last line, like that. This is placeholder stuff. It's a language. It uses all sorts of things. It adds value. But, you know, our course is going to die. Nobody takes it. It'll die. The methods and proof course will live, though. And that one's doing some of this stuff. So, here's more or less a conclusion. The world has changed. Information's incredibly cheap. Calculations are cheap. Most of the math we teach isn't worth anything. Maybe it's worth something, but you'd have to figure out what concepts it helps you get as you move your way up. Oh boy. I got some stuff coming. I'll show you what I'm talking about. Learning to read is not easy. It took your mom a lot of effort to get you to learn to read. It took you a lot of effort to learn to read. And we need to help them. I'm going to talk a little bit later about Bloom's taxonomy, which maybe you've heard has to do with how complex information is and that sort of stuff. And I'm going to skip all of this and go back to my duck can. Okay. I need to talk to you about what calculation technology can do. This is not the same as D2L. Calculation technology. Calculation technology can give you the ability to do more examples in the same amount of time. That's a virtue. And it allows you to focus on the point instead of the calculations. That's a virtue. So if I did let's suppose I do a factor theorem like this. I want to factor x squared minus 6x plus 8. And what I do is I have them graph it, and they see that it crosses the axis at 2 and 4, and then I tell them it factors in x minus 2 and x minus 4. And I can do several of these problems very rapidly, because the TI graphs very rapidly, and then they're supposed to get the point. They're supposed to figure out what they had in common. And I think that's abstraction. I'm going to take many examples and turn it into one thing, try to have them get the point. And I think there's no better way to do that than in language. But there's a danger with calculators. Look at this. Suppose I multiply 2-digit numbers by 2-digit numbers, and I have my third grader do that 50 times. What have they learned about multiplication? Probably nothing. Why would you learn anything if you don't abstract something from what you do? And how are you going to abstract something from what you do? Well, I don't see how to do it without the proper language. But, you know, maybe there are things that students need. Maybe students need to learn how to multiply two-digit numbers by two-digit numbers. Occasionally I have to multiply a couple numbers by each other. I'll search hard for my TI so I can do it. I know how to do it by hand, but I don't. And neither do you. But you know, when you do graphing calculators, a lot of things get skipped. Do the students understand graphs when the calculators do it? Answer, no. They don't know what those points refer to. And I can give them a nice word problem and give them the graph, and there's the graph, and say, what is that point talking about? They don't have any idea. The calculator drew it. Why should they know what it meant? Well, oh, Gad. Okay, I want to talk about calculus a little bit. I think Jack is changing calculus much for the better. But I'd like to know what the purpose of a course entitled calculus is. That's not the same as the purpose of calculus. I mean the purpose of the course called calculus. Is the purpose to teach students how to compute derivatives? Well, when I took it, the answer was yes, because you needed to compute derivatives and there wasn't any other way. Except I've already given away my books of all the derivatives in the world in big tables. All the integrals in the world in big tables too. Is the purpose of calculus so they can compute integrals? You know, normally I would pause and we would have a discussion. But you know, when you want to cram 40 years into a certain amount of time, you don't pause as much as you might otherwise. So, I'm wondering, what fraction of our students need to know integration by parts? I think it's a darn small fraction. I don't think it does them any good to know integration by parts, unless they're going to turn into a math professor like me or a few of you others. Mostly, if you need to integrate, get a machine to integrate. Last time I taught calc, a little bit later Wolfram Alpha came out. And I took the final exam on Wolfram Alpha. And I gave myself one skill. I knew where to put the parentheses, which is a little tricky. But I didn't know anything else. I just said, you know, find the derivative of this and just typed it in and stuff like that. And it was, I thought it was a pretty good exam. Well, Wolfram Alpha got a 71%, which was a B. And the reason it didn't do better is because they had true false and I didn't know how to type them in. And they had a few word problems and I didn't know how to make it do it. Wolfram Alpha says they're working on being able to do word problems. I don't see why they can't. And here are the problems that weren't word problems. I photocopied them here, and they're a little small, so I'll see if I can make this a little bit bigger. Okay, circle the correct answer. Let's just do problem A. Well, this was hard for the students because they didn't know what the integral of 1 minus the absolute value of x was. That wasn't one of those things you studied. So the correct answer is, somebody? If you think of area under a curve, and you don't worry about the fact you thought you were being examined on how to find indefinite integrals and plug in the endpoints, then that problem's not so hard. Let's see, isn't that something, let's see, absolute values like, so this is like that, isn't that sort of a triangle? And it's base 2 and height 1, I think it must be answer 3. Now, look at problem B. Now, I actually know how to integrate cosine squared, but a lot of students in calculus don't know how to integrate cosine squared. And I didn't write this problem. Marcy Barge wrote this problem. I thought it was a good problem. Marcy Barge wrote this problem. And it seems to me that cosine squared is greater than or equal to 0. And the interval is 2 units wide. So this thing is higher than 1, 2 units wide. I don't know what the integral is, but 1 by 2 is at least 2. So I'm going to go for 3 again. Now, this one has been used again by people like Nora, who some of you know who Nora is. Let's suppose you want to integrate x over x squared plus 1. Well, that's a quotient, right? So the integral ought to be the integral of the top divided by the integral of the bottom. Well, maybe not. Well, that's x times something which would integrate the arctangent. So the integral must be x times, no? Maybe it's problem 3 again. Can you do t? Somewhere along the way you learn that x squared plus y squared equals 1 is a circle. So x squared plus y squared is 4 is an even bigger circle. The radius 2. So that's the circle in the first quadrant. Let's see, pi r squared or something like that. I ought to be able to figure out what'd you get? R squared. I'm thinking maybe we get pi. I guess every answer was 3. People can't do that. You can't have 4 3s in a row. Well, I was grading this problem, and I noticed something fairly early on. I was grading lots of sections. So I decided to keep track. If they'd have tossed a coin, they would have done as well. Period. I am not talking, they did slightly better than tossing a coin? No. They did equal or worse than tossing a coin. So conceptually, what we were trying to get through about calculus didn't work. Computationally, they were okay. Computation is a lower level skill than understanding what's going on. Computationally, they were okay, and their dollar value is 0. I'm going to have a machine do that, thanks. You can integrate? Who cares? Wow. You know, I wonder if we ought to have some sort of calculus reform. Well, we tried that already. Didn't work. I'll tell you why calculus reform doesn't work. Concepts are hard. And people have a hard time getting concepts. They can finally get to the point where they can do computations in calculus. And then they think they're good at math, which the rest of us don't think because they haven't done methods of proof and all that sort of stuff yet. But it's really hard. And if you ask people conceptual questions, they don't do well. That's why curves have 50 for a C minus. They don't do that well. Well, you just have to give them concepts and give them concepts and eventually build them up. So I think we have a question. What do they need to know in these low-level courses? How about 121? How about college algebra? How much of that stuff is worth anything? Am I being negative? Yes. How much of that stuff is worth anything? Not much, except insofar as it builds concepts. And I think all of that's functional, so they need to learn functional notation, f of x, all that sort of stuff. You're just going to have to lower the curve. You're just going to have to say, okay, 80 is a pretty darn good score, and 60 is fine, etc. Okay, I'm doing some other random things. Teaching evaluations. Look at those forms we're sending out. I'm glad they're going to change them. There's not a single question on those forms that has anything to do with whether the student learned anything. Not a single question. I thought the purpose of the course was so the students would learn something. Not according to our teacher evaluations. I hope they change that a little bit. But it doesn't need to be 18 dimensions like they're talking about. I think you can find out whether they learned something and a few other things like do they like you in fewer questions than 18. Now, how do you get the students to do well? We have student success coordinators who are supposed to increase the fraction of people getting a C minus or better. Well, how are you going to do that? It would be nice, you know, ask my TAs. Ask any TA of mine. He'd say, if they would just come. Or ask my student success coordinator. She'd say, if they would come. I email them and say, why don't you come to this review session? We've got special review sessions just for people like you. 1 out of 50 turns up and stuff like that. They don't care. The reason they're not doing well doesn't have that much to do with how smart they are. Maybe some of them, but mostly not. They're just not that interested. There's a lot of other things going on. How are the incentives aligned? What would make the students do well? Oh, I got a good idea. Penalize the university unless we make a higher percentage pass. I know how to do that. My 50 has just been promoted to a B. Are they idiots? Do they really think that their incentives are going to make students do better? They make the faculty work harder, but they don't make the students do better. Yeah. All the alignments are toward pressuring the faculty. Now, I got a quote here, second paragraph down. I like this quote. The purpose of a liberal education is to make your mind a pleasant place in which to spend your time. I used to say this a fair amount, but there's no point anymore. It's not true anymore. Because students don't spend any time in their mind. Because as soon as they had the chance, they were on their phone instead, or listening to music. There's not any time to be in your own mind. I had it on my door for years, but forget that. I want to talk about hiring. I was on a hiring committee last summer, and you had to go through a half an hour of an online thing where they quizzed you, so you knew the rules. And they mentioned that at MSU, we have rules which say, if you take any notes in the hiring process, these notes have to be under lock and key for 3 years. So they told us, don't take any notes that you don't want anybody to see. And they mentioned that in a previous hiring thing, somebody had not been hired. And they asked to see the notes. And somebody on the committee had written elderly gentleman in the margin. $20,000. MSU had to pay $20,000. Age discrimination. 2 words. I think the guy was trying to remember who the heck it was. We had 30 people apply, trying to remember who it is. Long hair, elderly gentleman. I don't think anything's going on there, but yeah, with the cost of lawyers, $20,000 is cheaper than that. Now, I'll talk to you about my hiring. Hiring has changed. In December 1, 1975, things were going on at Cleveland State University where I was a faculty member, and I didn't like them. So I thought it would be nice if I could go somewhere else, and my wife said, how about Montana? She liked Montana. So I applied to here in Missoula, not because they had a job opening. As far as I knew, they didn't. I just wrote a letter and said, here's my qualifications. I was pretty sophisticated in statistics and probability theory and a few other things at the time. And I sent it off December 1st. And mid-December, I got a phone call from Ken TR. And he said, we want to hire you. And, whoa, what? You haven't interviewed me? Nothing's happened so far. I said, if these guys want to hire me and they don't even want to interview me, I better come out and see. So I got my wife, we hopped out in the car, and we got here on December 22nd. That's the day we celebrate as first coming to Bozeman. And I actually did meet him, and I like these people. And I met with the dean, and they said, yes, we'll hire you. And on the 23rd, the wife and I went out and bought a house. And later that day, we drove back to Cleveland. I told my department head, I'm not coming back. We were on quarters at the time. You had quarters that went to Christmas break, and then it resumed January 2nd was the beginning of the second quarter. So he said, oh, can you find me a replacement? So I phoned University of Wisconsin, where I was from, and said, do you have anybody that wants a job at Cleveland State? Because I'm leaving them in the lurch because I wasn't coming back. Now, why do they have this position? I was replacing Mitch Billis. Mitch Billis, you can Google him. He's a terrific artist. He was an algebraist and an artist. He liked art better than he liked algebra. I think there are a fair number of people like that. But he quit. And when they knew he quit, my qualifications were exactly what they needed for statistics. I stepped in and taught probability, the 421 type course, stuff like that at the time. And I drove back to Cleveland, starting on the 23rd late, got there, told my department head by phone, actually a little bit ahead of time, called a moving company, because we owned a house in Cleveland, called the moving company, said, you guys got to come right away. And then we drove back. So I had driven from Cleveland to here, from here to Cleveland, from Cleveland to here, got back in time in the classroom on January 2nd. That wouldn't be legal anymore. Is it harder now? Is it harder now to be a teacher? Yes. Significantly harder than it was in my day. Well, think of it this way. I had to do new research. I did some cool research. But there's been 50 years of research on top of that since then. And if you want to do anything in the area I was in, forget it. It was dead 40 years ago. I did everything. So did the area. We killed the area, and then you had to go out and find something else. What you got to do is mathematical biology with Tomas, because biology is the stuff from this century, you know. And yeah, an awful lot of stuff. You know, they say information doubles every 7 years or 10 years. How the heck are you going to get to the edge compared to me getting to the edge? Maybe pick something really narrow, maybe something like that. How are you going to play with all the rules? Wow, there are a lot of rules now. Ask Tomas how many rules there are. It's just, we can't get somebody to be department head who wants to play by all those rules. Boy, that's really hard. And let's say you want a job. Okay, who was I competing with? Well, I was competing with sort of the best PhDs who were American. Now who are you competing with? Everyone. Oh, I forgot to say, the best male PhDs were American, because there weren't any female PhDs in those days to speak of, hardly any. So now, heck, you got to compete with guys from Eastern Europe, and they work. I don't see Tianyu here, but there's another part of the world where you got to compete with too. And then you've got all these women. They work harder than the men in my classes. So, hey, this is, yeah, I think it's a lot harder now than it was. You guys, do you think D2L makes it easier? I don't think so. I'm supposed to quit here pretty soon. Okay. I'll quit pretty soon. Just a second. Let's see. I got a slide I wanted to show you. Don't know where it is. Maybe over here. Yeah. The bottom here has two of my favorite books. Influence, The Psychology of Persuasion. That is the most significant book I think I've ever read. Read it. It will save you many, many dollars. Because you won't buy stuff you don't really want. Thinking Fast and Slow is a fairly new book. Nobel Prize winner type guy. Very good about why students are so hard to teach. And, hey, it's been a great run. I had a terrific time. Thanks.